All right, Chapter 7, Lesson 5 talks about similar triangles and indirect measurements. So we've been talking about similar triangles for a while now. So they are triangles that are the same shape, not necessarily the same size. One is bigger, smaller, dilated than the other one. So, but they do have things in common. So the first thing that they talk about are angle-angle similarity. Now, we have talked briefly about proofs. We had one lesson on proofs. It was an introduction to proofs. I told you I was going to be very lenient on what I would accept for an answer. And so more or less it was just to get your feet wet. Well, whenever you get to high school and you have a geometry class, they are formalized proofs and they are very rigid, almost like you are in court and you are trying somebody for a crime. You have to have specific evidence to make sure that this happens. Well, there are ways to prove without a doubt that something is similar. One of those ways they are going to teach you today is angle-angle similarity. And here's what it says. If there are two angles, there's one pair, there's the other pair. If they have two angles to be congruent, then the triangles are similar. So think about that. If this one is similar to this one, and this one is similar to this one, wouldn't that force this one to be the same as this one? I mean, there's only so many ways it can add up to 180, right? So it's saying then that something is similar if all angles are congruent. So you don't even have to know that all the angles are congruent. If you can just prove that two of them are, then you know that the third one has to be. So that is angle-angle similarity. The AA is talking about two angles. If you know that two angles are congruent, those triangles are similar. All right. So let's look at example 1 right here. It says determine whether the triangles are similar. If so, write a similarity statement. So it says angle A and angle E have the same measure. Angle A, angle E. That's that 62 and that 62. So out of our two angles that we have to have be the same, we've already got one of them. All right. So now we have to see if there's another one. Well, the only other two that it shows is that this one's 48 and this one's 70. So right now you don't know that, but you don't know what this one is and that one is. So let's try and find them out. So if you know that the three angles add up to 180, I can add these two together. So 62 plus 48 is 110. 110. So if those two are 110, then that forces this one to be 70 if I subtract that from 180, because that's how many is in all three. Subtract the amount that are in two will give me what's left over in the third one. So right there, if I know that this one is 70, that one already matches up with that. Therefore, that is my second angle. 162, 170, 162, 170. Therefore, I know those two triangles are similar. So my similarity statement, triangle ABC is similar to, now remember the other day we had this, an equal sign with that swoosh above it. And that's why I kept saying that that is similar and congruent. Those are similar and congruent. Congruent means the same, so that's the equal. This is a similar statement. So we're not putting all of it because those two are obviously not the same thing. So they are not congruent, but they are similar. So triangle ABC similar to triangle EFG. Okay. Now, with this one down here, usually I have you pause it and try it, but I do just want to go through it quickly with you. Because obviously one of them you should pick up on right away. This angle and this angle, both 110 degrees. So it has one of the angles it needs. Now it just needs another one. But the problem is that you don't know anything about these. You don't know a measurement on any of them. So the only thing that you really can do now, since you don't know a number, is to look for relationships. First of all, are there any parallel lines? I don't see any. So the only relationship that we have for angles that are not part of the whole parallel line construct are vertical angles. And if you will notice, these two right here are vertical. Remember that vertical meet at a point. Vertical meet at a point, like this angle right here, and let's say this angle right here. Those are vertical because they meet at that point right there. So whatever this one is, this one is. So even though I don't know the exact measurement of those two, even though I don't know the exact measurement, it doesn't matter. I know that they are the same. So if these two are the same and these two are the same, then the triangles are congruent. So our similarity statement would be triangle JKH similar to triangle MKL. L. So triangle JKH is similar to triangle MKL. Okay. Moving on. Now, so what? What do you do with that? Well, you can use similar triangles to solve problems. And there is always one like this on ISAT usually. Study Island, if you remember this would be like the man in the tree. Anything that talks about shadows. So one type of indirect measurement, it says it's called shadow reckoning, which basically says that two objects and their shadows form two sides of right triangles. So if you think about, you're standing, come on. That's a crazy looking head. But you're standing here, the sun's up here, it's shining rays on you, you're going to cast a shadow back this way. Now, let's say your little brother is here. He has a nicer shaped head than you do. The sun is still shining. He's going to cast a smaller shadow than you. So basically what it's saying is that these are two sides of a right triangle. Okay? So that is basically like your right triangle right here. So if you know how tall you are and the size of your shadow, you should be able to figure out that side. Or if you know this side and this side, you should be able to figure out that one. So that would be Pythagorean theorem. But you could also do it using proportions, such as in example 2. A fire hydrant is 2.5 feet high, so right here, 2.5 feet high, and it casts a shadow that's 5 foot long. How tall is a street light? So you don't know how tall a street light is, but you can figure that out if you know how long the shadow is. So you could go measure the shadow, use that similar triangle right there, and then you could figure that out. So set up a proportion. So we've got small is to big. 5 is to 26. So I'm writing a ratio of corresponding sides. 5 is to 26 as, go back to small, 2.5 is to h. So 5 is to 26 is 2.5 is to h. Remember, cross products. So I got 5 times h, which is 5h, equals 26 times 2.5. Happens to be 65. That equation, we would divide both sides by 5. H is equal to 13. So that means the height of that street light. The height of that street light would be 13 feet. All right, so similar triangles, that's what we're talking about. And you can make similar triangles with shadows and heights of objects. So let's look at example 3. In the figure at the right, triangle DBA. So triangle D, oh, come on. DBA. So that's that one right there. All right? So it's saying that that is similar to triangle ECA. ECA. So what I want you to realize is that shape is actually two triangles, like one put on top of the other. All right? So if it helps you to kind of separate them out, I know that this is ECA, and then I could have my blue one smaller this way, BD. Now again, this is just for our reference, so they don't have to be perfectly similar, but just that way you've got an eye of it. So that way you can do that. You don't have to. But what I want you to be able to realize is corresponding sides. All right? So corresponding sides, I know that this right here is 40. I know that the hypotenuse is 320. I do not, however, know this. I do know that this right here is D. Now, to get the whole top up here, it's not 162. 162 goes to right there. So to get that whole hypotenuse right there, I'm going to have to add 320 plus 162, and I get 482. Now I've got two sets of corresponding figures, two sets of corresponding measurements, so now I can make a proportion. So small is to big. Small is to big. 320 over 482 equals small is to big. 40 over D. Cross products. 320 times D, 320 D. Now get out your calculators for the next one. 482 times 40, they already have it worked out for you right there. 19,280. Divide both sides by 320. So D is equal to 60.25 if you do that on your calculator. 60.25 what? Make sure you are putting your labels on there. 60.25 meters. Okay. So with that, I want you to actually pause this last one. Try it. See how it goes from there. All right, back with me. At the same time, a 2-meter street sign casts a 3-meter shadow. Let's just draw a picture of what we know so far. We know that a 2-meter street sign is casting a 3-meter shadow. Okay? A nearby telephone pole, you don't know how tall it is. It's some amount of tall. Is going to cast a 12.3 meter shadow. But you don't know how tall this is. We're going to find out. How tall is a telephone pole? So what is a proportion that you could use? So small is to big. 2 is to x as 3 is to 12.3. 2 is to x as 3 is to 12.3. Cross products. 3x equals 12.3 times 2 is 24.6. 24.6, what do I do now with both sides? I divide them by 3. So x is equal to 8.2. Use your calculator to check me if you wish. 8.2 what? What are these? Meters. So 8.2 meters is my answer. So just know that you can set up similar triangles, especially with shadows, because the sun's in the same spot, so it affects everything the same way. So shadow reckoning, a way to find indirect measurement. Okay? So try the rest of those. If you have any questions, come see me. Good luck.